we're going to be discussing the product rule for exponents. If we have two variable terms and number terms with the same base, and they both contain exponents, the both bases would be like a t on each one, or x and y, or a number like 4 and 4. When we multiply these two together, these bases with the exponents, we're going to add the exponents to find our answer. This is our rule right here, as you can see. It's important that we recognize we have a to the m power multiplied with a to the n power. Notice the a's show the bases are matching. And that means our two powers, m and n, add together to find our answer. Okay? So for now, we're going to leave that answer 6 to the 7th unmultiplied. We're going to leave it as 6 to the 7th. Now, I'll be doing some examples, and I will explain what's going on in each example. For a, we have x squared times x to the 4th. What that means is we carry the base over, it's x to the 2 plus 4 power. And the new power is x to the 6th. This is what the product rule is. If I were to write it all out in expanded form, it would be x times x times x times x times x times x for a total of 6 x's, so to speak. So we have x to the 6th power. So we showed it in expanded form and in shorthand form, I guess you would say. My writing tool is not writing very well today, but we're getting through. Now we have our example B, 3 to the 5th multiplied with 3 to the 6th power. We're going to take the 5th power and the 6th power and add them together to have 3 to the 11th power. So, here we have 3 to the 11th power. Now, we're looking at example C now. We have the quantity, parentheses, 2 times x squared multiplied by 3x to the 5th. Now, the numbers have no powers, have no exponent associated with them. And they aren't the same base anyways. But we're looking at our x terms, x squared and x to the 5th. The bases match. Therefore, we can add 2 and 5 to get a new power for x. I'm going to stop here. First, we're going to pull out the coefficients. 2 times 3. Now we're going to look at our variable terms, our bases. Now that's the final answer, 6 x to the 7th. Now on our example D, we have 4 variables. All of them have different exponents. X to the 4th times x to the 6th times x to the 7th times x to the... there's no exponent there. Does that mean you have a 0? No. It's x to the first power. We don't write the first power down because x to the first power is just x. Okay. I'm going to show it now so we know what we're adding up together. Now, I'll add all these exponents together. 4 plus 6 is 10, plus 7 is 17, and 1 more is 18. That's our final answer. X okay, x to the 18th power. I think we get it now. Now we're going to example E. 3 to the 5th plus 3 to the 6th. They have power, both have exponents. The bases match, but we're not multiplying them. So we can't add the exponents together. This is not a product rule kind of problem. So as I said, 3 to the 5th plus 3 to the 6th. 3 to the 5th, we can figure out evaluate that answer, and then add 3 to the 6th. Now, moving on. Example F. Some students I've heard get confused. They think they have to square the first term and take the second term to the 5th power. We don't have to do that. Okay, and there we have it. It's hard for students to see this. Now the quantity x plus 3 is going to become could be a number. If we had a value for x, we could evaluate for a number. Now what that means is x plus 3 is the same base as x plus 3. It's handled the same way as if we had a single variable like x or t. So we take the base, x plus 3, and then add the exponents, 2 plus 5. Thank you. See you next vlog.